Bismillahirrahmanirrahim. Assalamu alaikum. I am Mahad Malik,
And I am Muhammad Shayan Asad.
and today we are here to present the phase number 1 of our course, Discrete Structures final project, which is termed as Graph Project. We will discuss some main important points discussed by Oberoi and his team. First of all, let's begin with the problem addressed by Oberoi and his team. They focused on detecting dynamic patterns in dynamic graphs through subgraph isomorphism. The challenge was to map a dynamic pattern graph to target a dynamic graph while keeping the sequence of events intact over time. Many existing methods reduce dynamic graphs to static ones, losing important time-sensitive information. Oberoi's approach preserves this temporal order, which is crucial for fields like bioinformatics, social networks, and telecommunications. Now, next, I will discuss how their solution differs from the other one. Now, let's look at how their solution stands out. First of all, they use a snapshot-based dynamic graph model, which adapts to the VF3 algorithm, typically used for static graphs to work with dynamic graphs. One key feature is temporal pruning, which optimizes the search space and reduces computational overhead. Unlike previous methods, which often aggregate interactions, their approach keeps the time-sensitive dynamics intact, allowing for more precise pattern matching. Next is evidence of their superiority. Oberoi and his team's algorithm is not the most superior one, but they have mentioned that it is the second superior. The effectiveness of Oberoi's method was proven through experiments with real-world datasets. It outperformed other leading algorithms like Mackey's and temporal RI, both in terms of efficiency and accuracy. In particular, it excelled in scenarios that required detailed temporal analysis. The results showed that it maintained the temporal consistency of the graphs, all while achieving faster runtimes than its competitors. Now, Shayan and Asad will present the remaining points.
Now I am going to tell you about the code execution, the code that was given in the Oberoi papers, and the following by the steps that were given to run that code. We got this output by an IDE. In this output, first of all, we are going to check the input. What is the input of the code? First of all, the inputs include nodes that are defined by their IDs and labels, and the labels likely indicates the node attributes or their types. Then comes the edges. Edges connect nodes and are labeled with timestamps. And there are two different properties of the input: static properties and dynamic properties. Static properties include node IDs and labels, whereas dynamic properties include timestamps for the edges, showing changes over time. Next comes the output of the code. The output consists of two parts: nodes mapping and the solution count. In node mapping, there are two variables used. H refers to the nodes in the pattern graph and G refers to the nodes in the target graph. There is an example given in our slides that H4 matches with G7. It shows that the node 4 in the pattern corresponds to the node 7 in the target graph. Means that the pattern graph exists as a subgraph in a target graph, and the solution count is 1, indicating a valid subgraph isomorphism was found. Next, I am going to give the summary of the Bourgeasis paper. This is the figure 3 that is given by the Bourgeasis. In this figure shows the graphlet profile of two basketball teams, Spain and Argentina. Graphlet is a simple subgraph structure, and this figure illustrates how these structures were used during gameplay. Spain's profiles indicate that there are more complex graphlets compared to the Argentina, suggesting that they exhibited more variability and adaptability in their gameplay. Next comes the figure 4, which have two parts, the one with the transition profile and the other with the restricted transition profiles. As we can see in these figures that the Spain's transitions were more diverse, indicating greater unpredictability and adaptability. Teams with higher transition entropy, like Spain, tended to perform better, demonstrating the strategic complexity of successful teams. That's all from our side. Thank you so